welcome back to our channel. So in the previous session we have seen the radix sort or a bucket sort, right? So in this session we'll go with one more sorting technique, that is shell sort. So coming to this shell sort, first we are supposed to find the difference and we are supposed to compare the elements based upon the difference, right? So first we have to find the gap or a difference. Second, compare the elements with the difference or a gap. So we have to compare all the elements, those are having the distance between this difference, right? Next, this is completely done for one iteration, and for every iteration we have to reduce the gap or a difference by gap by 2 or a difference by 2, right? And at last at some or after some iterations gap or difference will be 1, so that apply insertion sort, or simply we can say this is a generalization of insertion sort. So we will follow the same procedure. How the insertion sort we have applied, the same thing we will apply for this shell sort also. So there in the insertion sort we are comparing the just adjacent elements, but here we have to find the difference and we have to apply the insertion sort with the gap of this particular difference. So let us go with an example so that if you are having any doubts, so it will be rectified, right? So we'll go with an example. So finally this is a generalization for an insertion sort. Okay, so let us take an example. So consider a few elements: 60, 40, 10, 30, 50 and 20. Let it be, these are the elements. So the index values are 0, 1, 2, 3, 4 and 5. So total number of elements are 6, right? Now we have to find the difference or a gap or a distance. We can call anything here, right? Distance is equal to number of elements by 2. Therefore distance is equal to 6 by 2, which is 3. See, in the first pass the distance is 3. So we have to compare all the elements which are within this distance. So let us take this index values and find the distance. So if you take the 0th index, what is the distance of what is the another element with the distance? It is a 3. So we have to compare these two. And if they are in a sorted order, nothing will be done. If they are not in a sorted order, just we have to make them in a sorted order. Just sorted order means just swapping. We will do the swap. Okay. See, 0 and 3. So this is the pass 1. In the pass 1, distance is equal to 3. Right. 0, 3. 0th element is 60. Third element is 30. So these two are not in ascending order. So just swap. So simply we can say 30, 40, 10, 60, 50 and 20. Right. Next, move the index value to 1. Move the index value to 1. So within the distance 3, what is the next element to be compared? 1 plus 3, that means 4. So the first element and fourth element should be compared. So what is the first element? 40, fourth element 50. So both are, see here, let us write the indication so that, right. So these two are in already sorted order, so nothing will be done. So just write down the elements. Right. Next, move the index 2. So within the distance 3, it should be compared with 5. So 2 is compared with 5. See again, here both are in a sorted order. So simply we can write 30, 40, 10, 60, 50 and 20. And move the index 3. What is the distance? What is the next index which we have to compare with these 3 indexes? 6. So this cannot be performed as we are not having the 6th index. The index last one is 5. We cannot compare it with the 6th index. So this ends our first pass. This ends our first pass. Next, coming to the second pass. So this is all about the pass 1. Coming to the pass 2, that means the second iteration we can call, right? So we have to reduce the gap. So this completely ends with the pass 1. That means we have compared all the elements which are within the distance 3. So 0th index element should be compared with the element which is having the distance 3. That means a third index. First index, fourth index, second index, fifth index, and third and sixth. So 6 is not available. So we have to stop comparing the elements. Now pass 2, we have to reduce the distance. So distance is equal to floor of distance by 2. That means floor of 3 by 2, which is nothing but 1. Right? Which is nothing but 1. So here the distance is 1. That means we have to compare the the adjacent elements. See, now in pass 2, the elements are 30, 40, 10, 60, 50 and 20. Now compare each and every element. So this is nothing but our insertion sort, because the distance is 1. So 30 is compared with 40. 30 is compared with 40. So first this is compared. So it will be 30, 40, 10, 60, 50 and 20. Now compare 40, element 40. So 40 is compared with 30. Yes, true. So 30, 40, 10, 60, 50, 20. Now compare 10 with 40. So if you compare 10 with 40, 10 is less than 40. So 40 is moved here. Next, 10 is less than 30. So 30 is moved here and 10 is placed here. So 60, 50 and 20. Right? So you can observe after every iteration the elements are being sorted. So after first iteration the first element is in sorted order, second iteration 2 elements are in sorted order, third iteration 3 elements are in sorted order, right? Now moving with the 60, right? So 60 is greater than 40, 30, 10. So 10, 30, 40, 60, 50 and 20. Now compare 50. 50 is less than 60. So 60 will be placed here. And now 50 is greater than 40. So 50 is placed here, 40, 30 and 10 and 20. Now compare 20. So 20 is less than 60. So move 60 towards its right. So 20 is less than 50. 50 is moved towards here. 20 is less than 40. 20 is less than 30. 20 is greater than 10. So here we have to place. Right? So after completion of all the iterations, we got the elements in a sorted order. So this is nothing but our insertion sort. This is our insertion sort, right? So one thing we have to remember that in shell sort, we have to first apply the distance, and based upon the distance we have to compare all the elements, right? So then at one step, at one iteration, the distance will become 1, so that it is completely of insertion sort. This is also an insertion sort, but here the distance is 3. Here the distance is 1. Right? So hope you understood this one. So let us take one more example with a more number of elements, right? So that we can get a 3 passes. See, I will take more elements. Some 80, 50, 60, 30, 10, 20, 40, 70. So 0, 1, 2, 3, 4, 5, 6, 7. So total number of elements are 8 now. Total number of elements are 8. So 8 divided by 2, the distance is 4. So we are supposed to compare 0, 4. So 0th element and 4th element. Okay. So here it is not in sorted order. So swap. So 10, 50, 60, 30, 80, 20, 40 and 70. Next, move the index 1. With the distance 4, we should compare 1 and 4, 1 and 5. So compare 1 with 5. So again those are not in sorted order. So swap 10, 20, 60, 30, 80, 50, 40 and 70. Next, move the index value towards right. So 2 with the distance 4, we have to compare it with 6. So 2 should be compared with 6. So also backtrack, right? So 60 and 40. Again swap 20, 40, 30, 80, 50, 60 and 70. Next, 3 and 7. 3 and 7, right? So 3 and 7. Again swap. So 10, 20, 40. Sorry. There is no swap. No swap is required because 30 is less than 70. 80, 50, 60 and 70. See, after the pass 1. So again move the index value. So you have to check backward also. So this is a third position. So backside 4 distance there is no elements because the backside distance is only 3 elements. So we need not go for the backtracking. So if increment this index value, that means the next way 4th must be compared with the distance 4 means 8th element. So where there is no index of 8, so we just stop here for the first pass. So this is the pass 1. This is all about pass 1. Right, pass 1. Now in the pass 2, what we have to do? We have to reduce the distance. So distance is equal to the floor of distance by 2 is equal to floor of 4 by 2 is equal to 2. So in the second pass, we have to compare all the elements which are at the distance 2. So consider this the same thing. Consider the same thing. So 10, 20, 40, 30, 80, 50, 60 and 70. So consider the first one. Coming to the index 0, 0 should be compared with 2. So 0th index is compared with 2. So they are in sorted order. Simply write the elements. So 30, 80, 50, 60 and 70. Right. Next, 1 with compared with 3. 1 is compared with 3. Right. So again they are in sorted order. 10, 20, 40, 30, 80, 50, 60 and 70. Next, 2 is compared with the 4. Second element is compared with the 4. So this is compared with this one. Okay. So 10, 20. So they are in sorted order. 40, 30, 80, 50, 60 and 70. See again. Right. Okay. So also check for the backing. Okay, backtrack also we have to check. So next 3, 5. Third element is compared with 5. So this is the third element. This is the fifth element. It's compared. So again they are in sorted order. 10, 20, 40, 30, 80, 50, 60 and 70. Right. Now see. Again, the third element is compared with 1 because the distance of 3 and 1 is 2, right? So far we didn't get in such a situation, right? So we are applying the 1 and 3, sorry, 3 and 5. We are comparing the 3 and 5. Okay, so if they are in a sorted order, we are not swapping, just we are writing here itself. And in the next time, we have to compare the third element with the first element because 3 and 1 is also having the distance 2. So if we have swapped the element, the element of third index will be changing, right? So we have to compare that third element with 0th element because the distance is 2. That also we have to consider. So again, here let us take this one. We have to consider this one, right? So 3, 0. So already in sorted order 10, 20, 40, 30, 80, 50, 60 and 70. Right? So next move the index to the next one, that is 4 to 3 to 1. Okay. Yes. Okay. Right. Next, see 4, 6. The distance is 6. The index value 4 must be compared with the element 6. So fourth element, what is the fourth element? 80 is compared with 60. So here there is a swapping. It requires swapping, right? 40, 30, 60, 50, 80 and 70. Now the fourth element has been changed, right? So previously the fourth element is 80. Now fourth element is 60. So backtrack. Fourth element should be compared with second element. Fourth element is to be compared with second element. So they are already in sorted order. See 10, 20, 40, 30, 60, 50, 80 and 70. And again, see, second element should be compared with the first one. So 2, 1. Again they are in sorted order. 10, 20, 40, 30, 60, 50, 80 and 70. Okay, hope you understood. We have to check for the backing also. So not only the forward, we have to check for the backward also. Now continue this one. So 10, 20, 40, 30, 60, 50, 80 and 70. So 0, 1, 2, 3, 4, 5, 6 and 7. Right. So after completion of this one, so next where we have stopped? The 4. We have stopped at 4. So now we have to compare the fifth with 7th. The fifth element with 7th element. Already in sorted order. So 10, 20, 40, 30, 60, 50, 80 and 70. Right? Okay. Now again compare. There is no swapping. So there is no value change at the fifth position. If the value is changed at the fifth position, we have to again compare the fifth position with the third position. And if there is any swapping, we have to compare again the third position with the first position. Right? So likewise we have to backtrack also. So not only the forward thing, we have to also compare the backward distance. Right? So next element is 6, 8, where the 8th index is not available. So just stop here the second pass. Just stop here the second pass. And now pass 3. What is the pass 3? Again we have to reduce the distance. So distance is equal to distance by 2. 2 by 2 is equal to 1. Right? Distance is equal to 1. So that is nothing but our insertion sort. See. So this is a pass 3. So first 10, 20, 40, 30, 60, 50, 80 and 70. So first 20 is compared. So 20 is greater than 10. So 10, 20, 40, 30, 60, 50, 80 and 70. Next 40 is compared. So 10, 20, 40, 30, 60, 50, 80 and 70. So this element should be compared with the leftmost elements. Right? Now 30 should be compared with the leftmost elements. So 30 is small than 40. So 40 will be placed here, 30 will be here. So again 30 is compared with 20. So 30 is greater than. So 30 can be inserted here. Right. 50, 80 and 70. Now 60. So 60 is greater than 40, 60 is greater than 30, 60 is greater than 20, 60 is greater than 10. So no change. 10, 20, 30, 40, 60, 50, 80 and 70. So now 50 should be compared. 50 is smaller than 60. So 60 should be moved here. And 50 is greater than 40, greater than 30, greater than 20, greater than 10. So 50, 40, 30, 20 and 10 and 80 and 70. Now 80. So 80 is greater than all the elements. So simply we can write 10, 20, 30, 40, 50, 60, 80 and 70. Now 70 should be compared. So 70 is smaller than 80. So 80 should be written here. And 70 is greater than 60, 40, 50, 30, 10, 20. So 10, 20, 30, 40, 50, 60 and 70. So this is the final result after completion of first pass. This is the final result after completion of the first pass. right? So hope you understood this one. So just we have to remember is, first we have to find the number of elements, and we have to find the gap or a distance or a difference. So based upon the distance, we have to compare each element with the another element which is available at this particular distance. Starting from the index 0, if it is a 4, distance 4, 0th element must be compared with the 4 which is having the distance 4, right? Next, first element, so just increment the indexes. So first element should be compared with the 5, second element should be compared with the 6, the third element should be compared with the 7. So if in the comparisons, if the elements are not in a sorted order, just we have to swap the elements. And then coming to the after completion of the first pass, in the second pass we are supposed to keep on reduce the distance. So in the distance, again the distance should be divided with a half, that means divided by 2. So in the second pass we got the distance 2, so we have to compare every element which is available at the distance 2. So from the forward direction as well as in the backward direction. So from the forward direction, 0th element should be compared with the second where the distance is 2. So similarly 1 is compared with the 3, 2 is compared with the 4, 3 is compared with the 5. Similarly, so if 3 is compared with the 5, if third element and fifth element are not in sorted order, just we are swapping, so fifth element will be now third element. So third element and which is having the distance of 2 from first element, right? So first element from first element also, the third element will be having the distance 2. So we are supposed to calculate, or we are supposed to compare the elements 3 and 1 also. So that's why we are specifying here, right? So 3 and 1. If there is no swapping, nothing will be done. If there is a swapping, we have to compare the 3 and 1 also. Okay, that's simply we call it as an insertion sort. We are applying the insertion sort, right? So normally insertion sort is applied for distance 1, and here we are applying the insertion sort for distance 2 and distance 4. So that's why we call it as a generalization for insertion sort. So we are supposed to compare all the previous elements, and then we are finding the position of the element and we are inserting that element into its desired position. That we are doing in the insertion sort. The same thing we are doing in this shell sort also. So hope you understood, and if you are having any doubts regarding this shell sort, you can post your doubts in the comment section, so that I will definitely try to clarify all your doubts. And if you really understood my sessions, like my sessions, share my sessions with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.